Hi students, this is Mr. Yang. Today we are going to talk about 4.16a, where we will learn how to do transformations with different functions. We have seen function graphs looking similar but also different before, and some of them could easily be obtained by making some changes from other graphs. This process of change is called transformation. There are several types of functions that we will actually explore in this lesson. We're going to explore linear, quadratic, square root, and absolute value. Linear, we're not quite going to use transformation because we have learned how to graph with y equals mx plus b. We're still going to graph it that way. That is still the best way. Each of these types could be considered a family of functions with unique characteristics that are shared among the members. The parent function is the basic function that is used to create more complicated functions within each function family. So we do need to understand what is a parent function, because understanding the shape of a parent function tells you whatever the function is, as long as following parent function, it's going to have the similar shapes. So first, linear function, the parent function is f of x equals x. It's basically y equals x. That's why it's a straight line from left bottom to top right. And these are the key features that you may need in the future. So it has everything: domain, range, intercept, interval, increasing, decreasing, positive, negative, max, min, and also it's an odd function because we have learned that because it's reflected over the origin and the end behavior. We're not going to focus on these. Instead, we are going to focus on the points we're going to use. So linear, the points we can use: -2 when it's -2. It's also -2 on the y. When it's -1, it's -1. When 0 is 0. When it's 1 is 1. When it's 2, it's 2. So these are the points. When we plot them, that's typically what we use. Next, quadratic. The parent function is f of x equals y equals x squared. So it's basically y equals x squared. And of course, that's going to be the graph right here. These are the key features that we have learned before. You can go over these, or when you need them in the future, you can refer here. The points we're going to use for these are -2, and when is that? -2 is actually at 4. Next one is -1, 1 is right here. Then it's 0, 0. The 0, 0 is on the line of symmetry. That's always kind of the middle point we pick. And 1 left, 1 right, 2 left, 2 right. So 1 and 2. When it's 1, it's going to be 1. When it's 2, the y value is going to be 4. So these are the points we are going to use, and you'll see what I mean. Now, another thing that's specific about quadratic is you can think it as from the middle point. When you actually want to get the next point, it's going to be 1 right, then 1 up, or 2 right, then 4 up. So you can also think it that way and use that for our transformation. So now let's have a look. Transformation. Once we know what the parent function looks like, we can use transformation to create a more complicated graph. We need to make sure we apply the transformations in the correct order so we get the correct picture. So this is very important. So let's talk about the order. First, we are always going to check about stretch and shrink. To check that, we're going to see if there's any multiplication or division going on in the function. So for example, let's say our function is -2, then x plus 3 squared minus 4. This -2 right here, that is actually the multiplication and division because it's -2 times the rest. And then we have a plus here and a minus here. We don't have any other multiplication going on. So that's always the first thing we check. We have a number that's being multiplied. We do. And next, we need to understand for multiply and divide, we can actually, that could happen either on the x, with the x, or not with the x. That's why we have a vertical stretch or shrink and a horizontal stretch and shrink. Here's how we decide on that. Vertical stretch and shrink, it basically means it's happening on the y. And horizontal basically means it's happening on the x. And we can see this, the parent function is going to be y equals, or f of x equals x squared. So if we think about it, if we do order of operation, we're going to need to add 3 first, and then square. After we square, it's going to be this whole thing times the -2. So basically, what I'm saying is this multiplication is happening after we do the square. So this is after. If it is happening after the square, it's going to be a vertical change. If it's happening after, it's going to be the vertical change. Happening after is going to be the vertical change. I say again, if we do the square first, when we calculate it out, if we calculate the square first, then we do the multiplication or adding or subtracting, that is going to be after the function which is vertical. That means all the horizontal ones are going to be before. Let me change the color so you can see it clearer. So this is going to be before, and here's what I mean. You see, if we want to calculate this out, we're going to need to add the 3 first, then square. So that means before I actually deal with the square, which is a function, I need to add a 3 before that. So that is before the function that is going to be horizontal. So now, the other thing special is, you see vertically, if it's greater than 1, yeah, it's going to be stretched, that's multiplication. If it's less than 1, that's going to be shrink. And if we have a negative sign in the front, which is after we actually do the square, so that's still after. That's still after. We have a negative sign in the front right here. That is going to be a flip over the x-axis. It's going to be a vertical flip over the x-axis. Lastly, you can see there I have this minus 4 on the end. That is also outside the square. That's after I calculated the square. So that is going to be going up or down. That is also vertically going up or down. Next, for horizontal. This is before. This is before. So these, again, the word before, that means it's happening before the function, before we do the square. So the plus 3 is the only thing that is happening before right here. So for horizontal, the opposite, the only thing special is for horizontal, everything's the opposite. I'll explain how to remember that in the next part. If it's greater than 1, it's going to be shrink. If it's less than 1, it's going to be stretch. And in this case, we don't have anything being multiplied with x inside the square, so there's no stretch or shrinking happening. Also, there's no negative sign before the x, right before the x, so there's no flipping. But we do have this plus 3, and again, that is add 3 first, then square, so that is before the function, which means it's horizontal. And if it's a plus, it actually means moving to the left. If it's minus, it means moving to the right. So this case is plus, so it got to be moved to the left by 3. Now a few more things. 1, with x, or you can think it as it is before the function. If it is before the function, that means it's with x. So because it's inside the parentheses, before you can either do square or do square root, whatever, before the function. Then it's happening on the x direction, which also means it's going to be horizontal. And if it's not with x, or in other words, after the function, this is going to be happening on the y direction, which is vertical. So now, another thing, we're always going to need to flip first before we can shift. We're always going to need to flip first. So we're always going to need to check that negative sign in the front. Negative sign in the front, before we can check all the adding and subtracting numbers on the end. The last thing, x are a little backwards, which is something we refer to as cheerleader effect. That means if you have a cheerleader and it's facing us, for example, when the cheerleader says raise your left hand up, we're going to raise our left hand up. The cheerleader is actually going to raise his or her right hand up. So horizontally, it's always going to be the opposite. When the cheerleader says raise your right hand up, we're going to do the right hand, but the cheerleader is going to do the left hand. So horizontally is always going to be opposites. Whenever it's x, is going to be opposite. Meaning if it's actually horizontal on x and is being multiplied with 5, let's say, we're actually going to do divided by 5 for the change. If it's adding 3, we're actually going to do minus 3. And in that case, that also tells you horizontally, if it's adding 3, it's actually moving to the left. If it's minus, let's say minus 4, that's actually going to be add 4 in our actual table, and that is going to be moving to the right. So that's the cheerleader effect. But vertically, it is exactly what it is. So this is only for horizontal. Vertical is exactly what it is. Add for up, minus for down. We're actually going to skip example 1 because, like I said, that is just y equals mx plus b. You can simply do 3 here and down 2 over 1, down 2 over 1 to actually get that graph. So we are going to skip that example. Let's focus more on quadratic. So first, this is the vertex form for quadratic, which is something you have learned already. There's three things we are going to focus on. One is the a, then is the minus h, and lastly is the k. So first, let's talk about, again, this is when it's multiplication. We can clearly see the a is being multiplied with everything. That's why the a is going to be about stretch and shrink. In this case, more clearly, it is actually going to be a vertical one. Because if you think about it, you're going to need to subtract h first, then square, and the multiply by a is clearly happening after the function. After the function. That is why it's going to be vertical stretch or shrink. And in that case, if it's greater than 1, it's stretch, less than 1, it is shrink. If a is less than 0, that means you have a negative number, negative sign in the front. It's going to be flipped over the x-axis. Because again, it's outside, it's after the function, which is why this is going to be a vertical flip. Which, in other words, is flipping over the x-axis. Next, for h. This is going to be about shifting left and right because you're going to need to subtract the h first before you can square it. So this part is before the function, which is why that is horizontal. But these two are going to be after the function because you calculate the square, then you even already multiply by the a, then at the end you add on to the k. So it's greater than 0, it's up, it's less than 0, it's going down. Now let's get to the examples. Example 2. So these are going to be the points we use, -2, -1, 0, 1, 2, and 4, 1, 0, 1, 4. These are the points we are going to use. So let me put these points down, and you can clearly see this is a square, so the parent function is f of x equals x squared. Now, -2 is 4, -1 is 1, 0, 0, 1, 1, and 2, 4. So this is what the original graph is going to be. Now let's start thinking about the changes. Again, we basically look for three different changes. One, we're going to look for the multiplication, and two, we're going to look for the negative sign, and three, we're going to look for the adding or subtracting. So let's do it one at a time. First, do we have any multiplication in the front? Well, there's no number there, so nothing for 1. Next, for 2, do we have a negative sign in the front? Nope, there's no negative sign in the front, so also stop on 2. The next, we see, oh, I actually have this -4 right there. And clearly you can see I'm going to need to subtract 4 first before I do the square. So that is before the function. You don't have to write this down when you actually do the questions. I'm just writing it down so you can see. That is happening before the function, which means it's going to be a horizontal change. And it's -4. Remember, horizontally is always the opposite. So -4 is actually the same as adding 4, so it's actually moving to the right. So it's going to be a horizontal shift to the right by 4. This is to the right. Like I said, the horizontal is always opposite. So basically, we're actually doing adding 4 to all the horizontal numbers, to all the x. That now becomes 2, 3, 4, 5, and 6. After that, we are going to need to graph because we already have finished the last step. That's the only change. So now we are going to graph the last points we just generated. So these are the actual points we are graphing. 2, 4 is going to be right here. 2, 4. And next is going to be 3, 1. Then 4, 0. 5, 1. And 6, 4. These are our points, and that is our new graph. So that is example 2. Next, example 3. Same idea, the parent function is still y equals, or f of x equals x squared. So we already know our original graph is going to be still there, -2, -1, 0, 1, 2, and it's going to be 4, 1, 0, 1, 4. Next, let's do the changes. So again, we are going to need to look for all three changes. 1, 2, and 3. First is one is for multiplication, then is for negative sign. Last one is for adding or subtracting. We do have multiplication right here. And if you think about it, you still need to do the square first, then multiply by 1/2. If you think you're going to need to multiply by 1/2 first, that should look like 1/2 x and then square. That's different. So in this case, it is clearly happening after the function. So it is going to be a vertical shrink because it's less than 1 by 1/2. So that means I'm going to need to multiply everything by 1/2. That becomes 2, that becomes 1/2, that becomes 0, that is 1/2, and that is 2. Okay, that's the first change. Next, we're going to see if there's a negative sign in front. Clearly, there's no negative sign in the front. Lastly, we are going to check about the addition or subtraction. We have a -5. And you can clearly see we need to do the square first, then times 1/2, and at the very end, we're going to subtract the 5. So that is also happening after the function again. So that means it's going to be a vertical, because after the function is always a vertical. It's going to be a vertical shift. So -5, so it's a vertical shift down by 5. So I'm going to need to, since it's vertical, I don't need to flip anything. I just do exactly what it is. So I'm going to need to subtract 5. 2 minus 5 is -3. 1/2 minus 5 is -9/2. 0 minus 5 is -5. Next one, -9/2. And the last one, -3. Now, these are the new points I'm going to graph. The x didn't change. And these are the new points I'm going to graph. So let's have a look. -2, -3. -2, -3. That's my first point. Then it's -1, -9/2, which is right here. Then 0 is at -5. Then keep on going here. And the last point is going to be at 2, -3. So there we go. That's our graph. After the shift, after the change. That's example 3. Next, example 4. Ooh, it's getting more complicated. So, parent function is still f of x equals x squared. We already know it's going to start with -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. Let's check all the transformations. 1, 2, and 3. First one again is multiplication. Second one is subtraction. Negative. The last one is plus or minus. So let's start with the first one. I do see I have a 3 in the front. So that is clearly after I do the subtract 3 and the square, then I multiply by the 3. So that is after the function, which means it's going to be a vertical. Since it is vertical, that means it just follows. So 3 is bigger than 0. So it's going to be a vertical stretch by 3. So that means I'm multiplying all the y's by 3. 12, 3, 0, 3, 12. Next. We do actually have a negative sign in the front. So that is going to be flip. Again, that is after the function because I already calculated the square, then I have a negative sign in the front. So flip over the x-axis. So negative, that means I just need to flip all the y numbers because that's happening vertically. So it's going to be -12, -3, 0, -3, and -12. Lastly, I'm going to check to see if there's any addition or subtraction. First, I see there's a -3 right here. And that is before the function. It's a -3 because we need to subtract 3 and then inside parentheses, we will square that. So that's why it's before the function. That means it's going to be a horizontal change. So horizontal shift. And remember, horizontally always works backwards. It's a -3. So it's going to be a horizontal shift to the right by 3. And when we actually calculate it out, we are going to add 3 because again, the horizontal is always opposite. So -2 plus 3 is -1. Next one is 2. And then 0 plus 3 is 3. Then it's 1 plus 3, which is 4. 2 plus 3 is 5. And by the way, this is actually a 1. Okay. And lastly, we will have the +2 on the end. So that is clearly after we already calculated the square. So that is after the function, which means going to be a vertical shift up by 2. That means I'm adding 2 vertically. Again, that's vertical, so I don't need to change anything. I don't need to flip. It is just up 2, so +2. That becomes -10. That becomes -1. That becomes 2. That becomes -1. That becomes -10. So let's graph. The numbers we are actually looking at to graph are going to be these. These are our new x, these are our new y. So that's why we are going to graph these. 1, -10, 1 is at -10. Then 2 is at -1. 3 is at 2. 4 is at -1. And 5 is at -10. So there's my graph. Okay, hopefully with these examples you are kind of following along, you are understanding the process. Now the last two examples, we are going to do things slightly backwards. For this one, write the equation of the function after each transformation is applied in order to the graph. So first, vertical shrink, that means it's going to be outside the f of x. So my new f of x is going to be, is a vertical shrink by 1/2. So 1/2 in the front, then x squared, because it's after we calculate the square. Next, reflect across the x-axis. That is going to put a negative sign in the front, so it's going to be -1/2 x squared. And lastly, shift up by 4. So that is a vertical change, which means it's got to be outside the function again. So f of x equals -1/2 x is outside the whole function, outside the square. So it's going to be a +4 on the end. That's example 5. Lastly, example 6. X squared is going to be a vertical stretch first. So f of x equals a vertical stretch, which is going to be a 3 outside the square. We calculate the square first, then multiply by the 3. Then we have a shift down. That clearly is going to be a 3x squared in the front, but it's down, so it's got to be a -2 on the end because that's a vertical change. But we still have this right 4. So f of x, again, right 4 is a horizontal. Horizontal is always opposite. So right is actually a -4. It's got to be x -4, and we keep everything else. We still have the square. We still have the 3 in the front after we calculate the square, and we still have the -2 on the end. That is example 6. Now that is everything for 4.16a. Thank you.